Assalamualaikum everyone. Welcome to our group video presentation. Today we will be sharing with you one of the important topics in linear algebra. We are from JCDCS 143 class 4C. Before we start, let's get to know our group members. I'm Nur Ali Amanina binti Nur Azman.
I'm Fariha Iliani binti Zulkifli.
I am Surya Afrinati binti Muhammad Alifti.
I am Putri Sri Farnagiha binti Syairi.
So let's speaking. In this video, we will present about application of Gauss-Jordan elimination in ratio of quantifying spot analytics. Before continuing our presentation, I will tell you guys about Gauss-Jordan elimination method. Gauss-Jordan elimination method named after two mathematicians, which is Carl Gauss and Wilhelm Jordan. This method is actually the extension of the Gaussian elimination method. The augmented matrix is reduced to a RREF, and then the RREF convert back to a corresponding system of linear before it's solved.
Okay, let's proceed to our presentation. First and foremost, I will talk about our introduction of the case study. In this study, we are analyzing a basketball scenario where each player has a different score for three key performance metrics. We have field goals, steals, and rebounds. We focus on these three key actions because they directly determine a player's total contribution to the final score. To give you an overview of our data, we have three players. For players A, we record as 4 field goals, 1 steal, and 3 rebounds. And for player B, we record as 2 field goals, 3 steals, and 1 rebound. And lastly, we have player C. We record as 3 field goals, 2 steals, and 5 rebounds. The question is, what is the problem statement?
So the problem statement is what is the individual point value of each type of game statistic produced by 3 top players, which game action give the highest points. The recorded match data shows total of 29 points for player A, 21 points for player B, and 31 points for player C. Next, I will explain about the purpose of our study. We have 3 purposes of study. First, to construct a system of linear equation from the match statistic and represent them as an augmented matrix. Second, to apply Gauss-Jordan elimination method to determine the exact point values. Lastly, to identify which game action contribute the highest point. So without wasting time, I will pass to Iliani to show you how to solve the matrix and get the answer.
Moving on to the methodology, we solve this problem step by step using Gauss-Jordan elimination. In step 1, we begin by defining our variables based on the problem text. Let A represent the field goals, B represent the steals, and C represent the rebounds. In step 2, we use the problem data to formulate our system of linear equations. This gives us 3 equations. 4a plus b plus 3c equal to 29, 2a plus 3b plus c equal to 21, 3a plus 2b plus 5c equal to 31. Next, for step 3, we transform this linear system into an augmented matrix so we can easily perform row operations. Now, let's begin the row reduction process. In step 4, our goal is to clear column 1. To get our first leading one, we multiply the entire first row by 1 over 4. Once we have that leading one, we move to the step 5 to eliminate the remaining elements in column 1. To turn the 2 and 3 in the first column into zeros, we apply 2 row operations simultaneously. Negative 2 row 1 plus row 2 becomes the new row 2. And negative 3 row 1 plus row 3 becomes the new row 3. This leaves us with zeros underneath our first leading one. After that, the next part of our row reduction process, we are going to focus on clearing column 2. In step 6, our goal is to get a leading one in the second row. Right now, the middle element is 5 over 2. To turn this into a 1, we multiply the entire second row by its reciprocal, which is 2 over 5. As you can see on the right, after applying this row operation, our new row 2 becomes 0, 1, negative 1 over 5 and 13 over 5. In step 7, we use our new leading one in row 2 to clear out the rest of column 2. We do this by running two row operations at the same time. First, we multiply row 2 by -1/4 and add it to row 1 to cancel out the top entry. Next, we multiply row 2 by -5/4 and add it to row 3 to cancel out the bottom entry. This gives us clean zeros both above and below our leading one, leaving us with this updated matrix. Moving on to step 8, our goal is to get a leading one in the third row. So we multiply the entire row 3 by 1/3, which changes our matrix entry to 1 and the constant to 2. Next, in step 9, we use this new leading one to completely clear column 3. We perform two row operations at once. We multiply row 3 by -4/5 and add it to row 1 to cancel out the top entry. And we multiply row 3 by 1/5 and add it to row 2 to cancel the middle entry. This successfully transforms the left side into a clean identity matrix, leaving us with our final solutions of 5, 3, and 2. So, here are the full steps of the solution.
So now I will explain about our result. So based on the Gauss-Jordan elimination method, the values for each game statistics were successfully determined from the system of linear equations. The final answer that obtained are field goal A equal to 5, steal B equal to 3, and rebound C equal to 2. This means that each field goal contributes 5 points, each steal contributes 3 points, and each rebound contributes 2 points. Okay, so next, I will explain about our discussions. So, from our study, we successfully applied the Gauss-Jordan elimination method to solve a real-life problem in sport analytics. By constructing a system of linear equations based in the player's match statistics, we were able to determine the hidden point values for each basketball action. The results show that field goals are worth 5 points, steals are worth 3 points, and rebounds are worth 2 points. These values were derived from the total match statistic of 29 points for player A and 21 points for player B, 31 points for player C. This proved that field goals contribute the most to a player's score compared to the other game statistic. We have proved that using the method, we can determine the exact point values for each player and identify which game action contributes the highest points.
Last but not least, to conclude this case study, exactly apply Gauss-Jordan elimination to determine the hidden scoring values in a fantasy basketball league system. By converting player statistics into matrices and solving linear equations, the exact point values for field goals, steals, and rebounds were identified effectively. Instead of relying on gut feelings, coaching staff and managers can use these exact point values to build smarter game day strategies and recruit the right players. By knowing exactly what each result is worth, the team can design plays that highlight their players' true strengths and win more consistently.